Hey there, it's Dr. Everybody. I'm going to talk a little bit here about programming project number 3 on Mastermind, the game of Mastermind. And some of you may not be familiar with that. We gave you a link in there. And the basic idea, this is a guessing game. So there's a secret key. In this case, it's got 4 colors, and your goal is to try and guess them, and the game gives you some feedback. So what you're doing is the computer isn't playing the game, you're just replicating what we're seeing here. So for example, if I picked these 4 colors, you see them showing up in the game, and I say check, and what we got here is right there is a black feedback. So there's 4 places for feedback, and the black says that one of those colors is correct and it's in the right place. We don't know which one, but one of them is correct. That's all I know. So that means 3 of those colors are not. Now this game allows repetition. We're going to play a simplified one that doesn't. So I'll just pick 4 other colors and check, and ooh, one of those is correct. So we know that maybe so 1 is correct. Yeah, it's a little hard for us to figure out what's going on here. So let's try something silly. Let's do 2 blues and 2 greens and see what we get. So no blues and greens in there. Oops, sorry. Okay, so yeah, there's no blues and greens in there, so I can say, how about these guys? Check. Okay, so now 2 of those are right. So which 2 are right? And you keep playing along with it. We don't have any right colors in the wrong places at this point. So well, let's see. I don't think any of these are in there, and they aren't. So we know that there's only golds and purples in there. Who knows? Maybe there's just purples. All right. And there are no purples in there. So maybe there's just 4 golds. All right. And we won. Now, unfortunately, that wasn't a very good game because we didn't see any of the white pegs. So let's do this again so we can see some white pegs. And there we go. All right, so now we got a black peg and a white peg. So the black peg means that one of these is the right color in the right position. The white peg means that I've got a correct color, but it's in the wrong place. And again, so we go through in this game 2, 4, 6, 8. There's actually 10 times. If you haven't guessed in 10 times, then you have lost. And the way this game gets set up is we go with we're going to go with 6 colors: red, yellow, blue, green, white, and orange. And when we, so rather than having pegs, these 4 mean that I've said a green, a blue, a yellow, and a red, which in that case actually won the game. So here's how the game starts out. We have to put in a secret key. We could have the computer randomly generate one, but it would be a lot harder for you to test and a lot harder for us to grade. So we actually know what the answer is. So there's a red, yellow, blue, and green. We do allow input to be the lowercase or uppercase. Then we describe the game. There's 6 colors. You got no repeats. And so then we can start playing the game, input a guess, blue, green, white, and orange. And then it says, how many do we have in the correct color and the right count? We have 0. Those are the black pigs from the game. And then what's the correct color but in the wrong position? There's 2. And in the video game that we had there, these were the white pegs. And we keep a history of guesses. So I put the guess, and I do that in caps, and we've done one guess, fine. And we're going to do some error correcting. Like, we only want these, red, yellow, blue, green, white, and orange. If somebody gives us numbers instead, okay, that's no good. So we say, all right, that's a bad guess. So then put another one. This one has an X, so that's bad. This one repeats. And although the game that we saw online allowed repeats, we're making your game a little simpler. That's not allowed. This one has more than 4 colors. That's not allowed. And then finally we get one that is. And notice that we keep a count of guesses, and all these erroneous ones don't count. It's only when we finally get a correct one that our guess now goes up by 2. So this is at the end of the description, and this is how your game will go. You input a secret key, you print out some instructions, and then you prompt for a guess. Take that guess in, provide some feedback, print out the history so people can see, much in the way the game we could see the past guesses we've made, and then we do some error correcting. And we tell you a lot in this game. We give you an outline of how it's played. Taking a quick look at that, we do. We take in a key, and then we start using guesses, and we keep looping around with that. And there's 4 things to check, or 3 things to check. Also, we allow lowercase. And if it's correct, we print out a message. If it was incorrect, or if we've gone through, if we've gone through 8 of them and we haven't got it, then that's wrong. And then then we print out some feedback. That's the black pegs. We've got some that are exactly right, correct. Should say character. I have to fix that. Correct character in the correct position. What happened? Where'd those come from? Correct characters. How many of the guess characters are correct but are not in the correct position? So the feedback will be 1 correct, so in this case, there's one's in the exactly right position, and 1 that is the right color and in the wrong position. And keep a history of the guesses. So we're trying to replicate being able to watch what's on the board. All right, so let's actually take a look at how we might do this. One thing we have to do is we have to take a key. So we have to say input, and you want to do something other than, a little fancier than that. Input a key, and then we get our first guess. Input a guess. And then I need to loop, and just as a starting point, you have to change this, but just so I have something to play with, and we have an error message there. Let's fix our typo. So let's just do while the guess is not equal to empty. And now, what are we going to do? So we provide a suggestion in terms of getting started. Prompt for the key, then loop and collect guesses into a string, print the guess string each time through the loop. And we're not going to check anything yet. We're not going to play the game, whatever. So let's just print the guess. All right, and ask for a new one. So here is my here is my standard loop, where I have a standard while loop. I have an initial value, I check that value, and then I get a new one at the very end of my loop. So there's your standard design of a while loop. It's got three parts: an initial value, a Boolean that checks that value, and then a new value. So we can check this out, see if this guy runs. All right. So we enter a key, A, B, C, D. It doesn't matter. We're not doing any checking. And it prints out the guesses, and I can keep doing this until I have an empty guess, and then it ends. By the way, if you forget to end a session, you can always go up here and restart the kernel, and that just clears everything, clears out your old stuff. Handy little thing to do. Okay. All right, what was the next? Oh, so it suggested that we keep a history. So the way we can keep a history is just take an empty string, and every time I take a guess, just add onto it. Plus equals, let's put a carriage return in there, and then print it. Oops, print history. And since I started my history with a carriage return, this will start them out printing those lines. If I have that print, let's get rid of this guy, run it, and okay, we put a key in and then a guess, and it starts printing out the history, and it keeps track. Notice how every time I add on there, my history gets one longer, and there's a little bit of a loop to get this thing started. And then once I've done that, then I can start adding some checking. So what kind of things might I check? Well, one of the things is that my guesses better be exactly 4 characters long, right? So if the length of my guess is not equal to 4, then I can get a new guess. We'll need a better error message than that, but that gives me something to start with, and then I continue, right? And remember how that works, where the what happens when I have a continue? Continue says go back to the top of the loop, skip everything that's below that. All right. So if I have a guess that's bad, hey, it doesn't have exactly four characters in it, then I want to go and go back and try. I took a new input and went back up to the top. So I got to remember to have the new input in there because that's how I end every part of the loop. Now let me give you a little bit of a hint here. Notice how I could have done this as that is exactly the same logic. All right. If the length is not equal to 4, or it's not the length equals 4, why would I want to do that? Well, I can keep adding ands in here of what the correct is. It's correct if the length of the guess is 4 and guess dot is alpha. It's only letters. There's no numbers in there. And so I can have this Boolean expression of all the things that are correct, and then say, oh, well, if it's not that, then I go and we'll say, okay, I've got an error. Let's go back and try again. So there's a little bit of a trick in terms of building Boolean expressions. It can sometimes be there to specify what you want as correct, and then say, hey, if it's not that, I've got an error, and we take some kind of action in there. So you'll be able to put into this the fact that we've got one of each. What you won't be able to put into this is that one of the types of errors that we check that won't fit in there is that we have exactly the characters, the RYBGWO, and I make a few comments down here below on that. So length, all right, you saw how I used that in error checking. We allow lowercase input, so just convert everything to uppercase and then we're consistent. You saw me use the is alpha for checking to see that I only have characters in there. You want to check for repetition, hey, count's good for that. You want to check for to make sure we have the right characters, then in that, checking that it's in that string is good. You want to go through and look at all the characters in the string. That's a way to do that, and in particular is enumerate. And you should try these things out in the shell. So for example, if I have a string A, B, C, D, and I say for I, CH in enumerate of S, if I print the I and the CH, what do I get? Out of that, you can see that I get, so I'm going to go through the string S, and I print out each character there, A, B, C, and D, but I also print out the index. And that's really handy when I have a key, like an A, B, C, D, and now I have a guess equal to X, B, Y, and D. How is it that I know, how do I check that the B and the D are exactly right? Well, if as I go through my guess, if I know my index, I can say, oh, I'm at index 1, what is the value at the key? And enumerate is one nice way to do that. Go through the guess, you get each character, in this case the B, but you also get the index, and you can use that to compare with the key. Hopefully that's enough to give you a start on this. Good luck.